All right, we're going to attempt here to show you some of the features of your TI graphing calculator when it comes to derivatives. So the problem that I'm looking at is asking me to find the instantaneous rate of change, or the derivative of y equals 2x times sine squared x minus 5 at x equals 3. So I'm going to show you one way how to do this from the home screen. And so let's first of all, well, go ahead and jump right into it. So the first thing we want to do is under the math menu, if we scroll down here, we see that there is a function in number 8 called inderiv. This is asking for the numerical derivative. Now, if you have a TI-83, it won't show up quite this nice. If you have an 84 with one of the new operating systems, then it's a lot more instinctive this way. So we're going to do ddx, and here we need to put our function in here. So we're going to do 2x times the sine of x minus 5, and we will close that. And on the other side, let's see, I'm going to put another parentheses there and put my squared out there. That will make sure that the sine of x minus 5, let's see, the sine of x minus 5 is the thing that gets squared. I chose that on purpose because I want to make sure we know how to put sine of x squared in there correctly so that we'll read it. And it says evaluate that where, and that's going to be at x equals 3. So we put that in there, and it tells us what the value of the derivative is at that point. Okay. If you have a TI-83 and not a TI-84, that command is going to look like inderiv, and that will show up on the screen there. And you're going to put the function in. So we'll put our 2x sine x minus 3 squared. I won't even put that, yeah, you can put the squared up there in that. And then comma x comma 3. And those are the pieces that you would need. So it says calculate a numerical derivative of this function when x is equal to 3. So that's what the command would look like on a TI-83. Similar things are going to happen in all of our other versions of this. So that's way number 1. That is from the home screen. Okay. We can also go in here and we can enter this function into y equals, and say I want 2x times the sine of x minus 3, close again, and square. And I think that is it. So let's try to zoom 6 and see what we see on there. So this is what the function looks like. And what we can do then is in the calc menu, so if we go second calc, we can choose down, and option 6, we see here says dy dx. We know that's a notation for derivative. And then we can say go to 3 and tell me what the derivative is at 3. And that is a completely different number than we got before, so we want to double check and make sure we put our function in correctly in the first place. I forgot to, I don't know, there's my squared. That should have been right. 5. Oh, I put an x minus 3 in here instead of an x minus 5. That was my mistake. So we'll graph that, and then we will try that again and see if we can get closer to that 6.19 or whatever it was there. So second calc, 6, and go to 3, and that is a more familiar looking number for us right down in here. It says dy dx is equal to that right there. So the third way that we can do this, I'm going to go back into the y equals again. It's kind of a combination of the two. I'm going to go up and turn this equation off because I don't want to graph it again. But I'm going to hit the math here and scroll down, or hit 8 to get the inderiv, and do the same things here. Now that I have that function in there, though, I can hit vars, y vars, 1, 1, and say take the derivative of the thing that I have in y1. And this time instead, I could put a 3 there, and it's just going to put a horizontal line in here. But I'm going to go ahead and put another x here, and exploit the graphing calculator's graphing features the way that it does that. And so now if I hit graph, then I'll see a very different looking graph that's not particularly fast. It's moving kind of slow here. This is not the graph of 2x times sine squared of x minus 5. This is the graph of the derivative of 2x times sine squared x minus 5. And you can see as long as it took to do that, why I didn't graph the original function on there with it, which would have also made a mess. But now instead of calculating the derivative of that, I can just trace to 3. And there is my 6.19 value over there like it was before. So that's 3 different ways to use your technology to come up with values of the derivative. I use them interchangeably depending on what it is that I'm trying to do at any given time.